the webinar. I will register also the webinar in order to give the possibility to other people to, if they are interested, to see this webinar. So we can start. Okay, so you can see my screen. Can you see my screen?
Yes, we can.
Very good. Ok, ammetti tutti. Okay, so the title is Production of Forage Quality in High Climate Change. As I said before, this is the second webinar that I organized for the Climate for Demo project. I still have more people to. Okay. And in the last webinar there was two speakers. One is Isaac Rossi, that my colleague Isaac Rossi, that he spoke about the forest challenge and adaptation, and he focused his presentation on the resilience strategy in the field level. So he spoke about the strategy, for example, is the early harvest or early cutting in order to manage fiber and protein content. And also he explained how the diverse crop rotation, like winter crop, can help the farmer to face the climate change, so that this could be an mitigation and adaptation strategies. Pasinato was the second presentation, and she spoke about the sustainable dairy intensification, and he explained how the living lag approach can help the livestock sector, the dairy farm, in fact, to increase the productivities, and at the same time to reduce the environmental impact of the dairy farm. So at the end of the webinar, the general result was that the high quality can help the farmer to be more resilient on external protein resource, and also give this help to reduce the global environmental impact. And so this is the mitigation and adaptation strategies. Harvest time, crop rotation, and precision feeding. But we know that when we are in the field, it is not enough to say that we have to harvest maybe the high before, or use the double cropping, but also is another important thing is how we would like to harvest. And how could be the more innovative techniques to harvest the high quality forage. So for this reason was organized this second webinar, where was involved the University of Modena Reggio Emilia, Professoressa Roberta Martelli and Lorenzo Frangiosi, where they will speak on precision forage harvesting, best practice for quality data and climate resilience. And then the second presentation will do by AG Open, and he will speak on the positive impact of precision moving and the ranking on feed quality. So this is a very short presentation, Now, I don't know if Laszlo wants to add some things, please. The floor is yours.
Yeah, thank you. Maybe just very brief at the beginning, and before the presentation of my colleague Balázs Bunic, I will also introduce him briefly. So I'm Laszlo. I'm working in ÖMKi. This is the Organic Research Institute in Hungary, and I coordinate forage production in the Climate Smart Advisors project. You already said that we co-organized one event last year on the topic of carbon farming, and also this year we had a separate knowledge exchange event regarding new forage strategies in the changing climate in Europe. And as you said, now we will focus on mainly how precision agriculture can support forage production and how it may even impact the quality of harvested forage crops. So for this, I invited an expert, Balázs, who I met in another project, recently implemented with ÖMKi's external participation, and that was the Agricultural Digital Innovation Hub project under the EU's Digital Europe program, where we mainly supported smallholders and family farmers in the digital development pathway, including forage production as well. So that's just for now, and I will say a few introductory words before Balázs will start his presentation after the next presentation. So thanks for now.
Okay, thank you, Laszlo. So now I will give the floor to Professoressa Roberta Martelli, that she would like to do an introduction, please.
Yes, an introduction. I would like to thank Dr. Zatta for his kind invitation in this webinar. I am a professor of agriculture, mechanics and mechanization at the Department of Life Sciences of the University of Modena and Reggio Emilia. Dr. Lorenzo Franciosi will present a contribution on the technologies currently available for precision forage harvesting in the context of climate change. The presentation will illustrate the most recent technologies to integrate harvesting operation with the collection of the data that can support farm management decisions. Lorenzo also will present on the latest development in adaptive control systems capable of adjusting machine operating parameters according to crop and field variability. I hope that you will find the presentation interesting. I will not be able to stay until at the end of the webinar, so if you have any question or would like further information, Lorenzo will share with us our contact detail to contact for some information in addition. Thank you very much and have a good webinar.
Thank you, Roberta, for your introduction. So now I give the floor to Lorenzo, and we can start going deep of the information on this webinar. Thank you.
Okay, thank you very much. Let me share my screen first. Okay. Tell me, please, if you can see the full presentation.
Yes.
Very good.
Yes.
Okay, good morning, everyone. First of all, I would like to thank Dr. Alessandro Zatta, Laszlo Gabor-Popowski, and CRPA for their kind invitation to participate in this interesting webinar. I would also like to thank all of you for joining us today. My name is Lorenzo Franciosi. Professor Roberta Martelli already presented me. I'm a PhD student in precision agriculture at the University of Modena and Reggio Emilia. Within the field of precision agriculture, my research activities focus primarily on the analysis of spatial and temporal variability of soil physiochemical properties and crop production, with particular emphasis on processing tomato, and that's me. My presentation will focus on the technologies currently available for precision forage harvesting in the context of climate change. Rather than simply referring to climate change, I prefer to speak about the increasing frequency of climate adversities. Prolonged droughts, temperature spikes, intense and unpredictable rainfall events, together with the progressive reduction of available operation windows, are making the production of high-quality forage increasingly challenging. In this scenario, harvesting is no longer just the final stage of the production process, but it becomes a strategic and critical operation during which a significant part of the final forage quality is determined. Today, I will provide an overview of the main technologies available for the precision forage harvesting, focusing on moisture, yield, and quality. Haymaking and forage harvesting, thanks to modern machinery, are evolving from mechanical operation into data-driven decision-making processes. Traditionally, management decisions were mainly based on the operator's experience, also visual assessment of the crop and weather conditions. Today, sensors installed on harvesting machines, GPS systems, and real-time analytical tools make it possible to transform harvesting into a true harvesting process. During machine operation in the field, it is also possible to acquire georeferenced information on yield, moisture content, and forage quality. This changes the role of harvesting. So it's no longer just the stage where the crop is collocated from the field, but it also becomes an opportunity to collect information that can support prevention, traceability, and feeding strategies. Within the same field, areas with different biomass, production, moisture content, and nutritional value may coexist due to variation in soil characteristics, water availability, but also microclimate and crop development stage. Climate change amplifies the variability that already exists in forage systems by introducing instability factors that increase the risk of harvesting at a non-optimal moisture content, dry matter and nutrient losses, and forage contamination. In addition, in many regions, the available operation windows are becoming progressively shorter, forcing farmers and contractors to make faster and increasingly precise decisions. Precision harvesting makes it possible to identify and quantify this heterogeneity through yield maps, moisture maps, and quality maps. In this sense, climate resilience depends not only on crop selection and agronomic practices, but also on the farmer's ability to monitor variability in real time and adapt harvesting, storage, and forage utilization. Precision means monitoring the system and adapting decisions that actual feed condition in order to harvest at the optimal stage, operate at the appropriate moisture content, minimize losses, preserve forage feeding value, improve the uniformity and the harvested product. Now, what are the key technologies for mapping variability? As you know, in recent years, there has been growing interest in the use of remote sensing technologies based on UAVs and satellite platforms to obtain information on the spatial and temporal variability of crop vigor and the occurrence of stress conditions. This interest is also expanding in forage production systems. The use of multispectral and hyperspectral sensor makes it possible to acquire high-resolution information on forage biomass and quality, allowing indirect estimation of several quality-related parameters. A lot of research is currently focused on identifying the most suitable vegetation indices for detecting and describing these characteristics. However, in this presentation, I will not go into details about this, but more about sensing techniques. Instead, I will focus on technologies that can be applied directly on the machines and that allow the acquisition of quantitative and qualitative information on forage during the harvesting process itself. Moisture monitoring is one of the most important aspects of precision forage harvesting. This is because moisture directly affects forage preservation, the risk of deterioration, dry matter losses, and the overall quality of the final product. Sensors installed on harvesting machines can continuously measure moisture content, reducing the need for spot sampling and subjective evaluations. The collected information can be continuously recorded and linked to GPS positions, allowing the generation of georeferenced forage moisture map. Several types of sensor for forage moisture measurement have been developed and evaluated in scientific literature, many of which can be directly integrated into harvesting operations. The table here summarizes the main sensing technologies reported in the literature. Many of these systems originated from research and prototype development activities and were later transferred into commercial applications. The simplest solution are contact and conductive sensors, which estimate moisture content by measuring the electrical conductivity of the material. Another category is represented by capacitive sensors, which estimate moisture content through the measurement of the forage dielectric constant. Microwave and radio frequency sensors have also been investigated. This system operates without direct contact with the material and can provide more continuous measurement. And finally, gamma ray sensing systems have been also evaluated in experimental studies. They are highly accurate, but their practical application is limited by safety regulation. These sensors can be installed at different locations along the harvesting chain, such as example on the header, along the crop flow path, inside the baling chamber, and on forage wagons and trailers. On modern self-propelled forage harvesters, the dominant technology is based on NIR sensing systems installed either along the crop flow path or on the discharge spout. As we know, these systems are able not only to measure moisture content, but also to provide valuable information on forage quality. In many cases, these data are also used to automatically adjust machine settings. One example could be the length of cut. Moisture sensing systems installed on balers are particularly interesting in my point of view because they allow real-time monitoring of moisture during a bale formation, reducing the risk of undesirable fermentation and quality losses during storage. In this slide, I've reported the two examples of the commercial available solutions. The first one is the system developed by Harvest Tech, where moisture measurement is performed directly in the bale chamber through resistive sensors, which with star wheel sensor for square balers or disc for round balers. The second is the system proposed by Vomax, which is based on microwave or radio frequency sensing technologies. These sensors work without direct contact with the crop and are less affected by crop variability. Yield mapping represents a key component of precision forage harvesting. However, in forage system, yield measurement is considerably more challenging than in grain crops due to the high variability in moisture content, but also crop density, physical characteristic of the material, and the continuity of crop flow during harvesting. Over the years, numerous experimental technologies have been developed for the forage yield measurement. In this slide, you can see a summary table comparing the main sensing solution that have been investigated in laboratory studies and prototype applications. As you can see, a lot of different sensing technologies have been investigated, including volumetric flow sensing system based on feed roll displacement monitoring, mass flow sensing system based on impact force and torque sensor, optical sensing systems, radar and microwave sensors, as well as LiDAR and acoustic systems. Several of these technologies were initially developed as research prototypes and later contributed to the development of the commercial yield monitoring systems, currently available on harvesting machines. Today, the major manufacturers of self-propelled forage harvesters integrate commercial systems for continuous yield measurement during harvesting. The most widely adopted commercial technologies are mainly based on feed rolls displacement sensing and crop impact force measurement in the discharge spout. Here we have some example. Class, for example, uses the quantimeter system for productivity monitoring. This system estimates the throughput using the position of the pre-compression rollers and the resulting crop flow. New Holland employs monitoring systems based on sensor installed on the feed roll linkage, enabling continuous measurement of crop throughput during harvesting. The collected data are displayed through the IntelliView interface. Prone, with Big X forage harvesters, integrates crop flow sensing system with combined with the NIR technologies. The crop control system estimates forage yield by monitoring the crop flow through the feed rolls. Yield is calculated from the opening and speed of the pre-compression rollers. Yield monitoring is not limited to forage harvesters. Today, several commercial systems are also available on balers, allowing the collection of valuable information directly during the baling process. The most advanced system can record bale weight, moisture content, GPS position, and machine operating parameters. Krone equips its big pack balers with an integrated bale weighing system installed on the bale chute. For each bale, the system records weight, moisture content, bale dimensions, and GPS position. New Holland offered the active weigh system on its big baler series. The bale is weighed directly on the bale chute immediately before being released onto the ground. The system displays weight and productivity data directly on the IntelliView terminal. John Deere actually adopts a different approach. Sensor installed in the pre-compression chamber floor continuously monitor bale weight throughout the entire baling process. This allowed the operator to monitor bale weight and density in real time, producing more uniform bales. However, one important limitation remains. During racking, windrowing, and baling operations, the forage moved from its original position within the field. As a result, the spatial location of the bale does not always perfectly correspond to the location where the biomass was originally produced, introducing some uncertainty in yield mapping applications. Nutritional quality monitoring is probably the most distinctive and innovative aspect of precision forage harvesting. For this reason, all major manufacturers, including Claas, Krone, and New Holland, are increasingly investing in NIR systems integrated directly into the discharge spout or along the crop flow path. NIR sensors installed on self-propelled forage harvesters analyze the reflectance of the harvested materials and allow the rapid estimation of several forage quality parameters. These including dry matter content, crude protein, fiber fraction, and GF, that is the natural detergent, and the digestibility. Information collected during harvesting can be used to separate forage lots according to their quality, manage store more effectively, and improve product traceability. So higher quality forage can be allocated to high producing animals, while lower quality forage can be used for less demanding animal groups. In this way, field data become valuable tools for improving ration formulation and increasing feeding efficiency. Therefore, the practical use of the harvesting data should include lot separation, selective storage, forage traceability, and ration optimization. In recent years, the real evolution of precision forage harvesting has been transforming information into automatic actions. For the reason, we increasingly talk about the transition, so from sensing to actuation, which means from information acquisition to the automatic execution of operational decisions. An example is represented by automatic adaptive dosing systems available on modern self-propelled forage harvesters. In this system, information collocated by sensor can be used to automatically regulate the application of inoculants or preservatives during harvesting, improving fermentation quality and silage preservation. Another example is represented by baler automation system, such as the intelligent bale automation developed by New Holland and the baler automation kit offered by Chase IH. These technologies automatically adjust several machine operating parameters, including bale density, bale dimensions, net or twine tension, and forward speed. A further example is represented by automatic guidance and windrow tracking system available on the latest generation of machines. These systems integrate optical sensor, cameras, and in some cases, laser or LiDAR sensors capable of detecting the position and geometry of the windrow in real time. The guidance system uses the information to automatically adjust the machine path and the forward speed. As a result, overlaps, missed crop areas, fuel consumption, and operator fatigue can all be reduced. Now, what is the actual level of adaptation of these technologies nowadays? How many farms are really integrating field-derived data into their own operational processes? With regard to yield mapping in forage system, which we know is one of the fundamental components of ADP, it is difficult to find precise and official statistics. Most adaptation data come from grain crops and large arable farming systems. However, USDA data show that yield monitoring and mapping technologies are now widely adopted by large farms in the United States. In 2023, for example, more than 68% of large US farms were using yield mapping and soil mapping technologies. As for Europe, however, in forage systems, there are still no official statistics. In any case, estimates indicate that adoption rates are still considerably lower than in grain production systems. But the growth trend is very clear, particularly in intensive livestock farms, agricultural contractors, and silage maize production systems. Despite their considerable potential, precision harvesting technologies still face several challenges. First of all, as we all know, investment cost, data management, interoperability, and the need of technical expertise continue to limit the widespread adoption, particularly in small and medium-sized farms. However, in forage production systems, where economic margins are often lower than in high-value crops, the future of precision agriculture will probably not depend on producing more data or maps, but on transforming information into actions in real time without the operator intervention. For this reason, I believe that the most promising direction is the additional development of adaptive systems capable of automatically adapting to changing field conditions. We have already seen this evolution through automatic adaptive systems, baler automation systems, and automatic guidance technologies, of course. And in general, with all the machine control systems that continuously adjust the operating parameters according to crop conditions. Looking ahead, we will see increasing integration of advanced sensors automation, artificial intelligence, and predictive algorithms. These technologies will allow machine to automatically adapt to forage quality, moisture content, crop flow, and operating conditions. In other words, the future of precision forage harvesting is helping machines to adapt automatically to field variability, ensuring higher forage quality and greater efficiency. Thank you very much for your attention. Today, unfortunately, Professor Berta Martelli, she's not available to do the presentation herself, so I'm conducting it for her. If you have any questions, suggestions, or just simply information, feel free to contact us. You can find us our email here. We will be very happy and truly happy to respond to all your questions and clarify all your information. Thank you very much.
Thank you, Lorenzo, for your very good and nice presentation and with really practical info that could be useful also for the farmer, not only for the researcher or for the advisor. So many thanks. If you agree, I will leave the question for the end of the webinars. And now I will give the floor to Laszlo to present his colleague, and then the other people can take notes on your presentation, Lorenzo, and then maybe for the question, maybe it could be interesting because then we can have some interaction between your presentation, maybe the next one. Thank you very much. Laszlo, the floor is yours.
Thanks. Yeah, I would like to ask my colleague to take the attempt to share the slides. Balázs is out in the field today, and he's on a tablet, but hopefully he can share the presentation directly from there. If not, then we will support him from the office. But looks like the presentation is coming, so that's nice. So let me introduce him very briefly. Balázs is one of the key technicians and advisors in the EGOPEN GPS initiative in Hungary. Maybe you have heard already about EGOPEN. It was started in America, but now it's becoming quite popular in Hungary as well. Maybe Balázs, if your mic is not muted, you can mute it for this 1 minute introduction, and then you can unmute it when you speak.
Sure.
Balázs is a farmer as well, and the whole EGOPEN community is developed by farmers for the farmers. But he's also an advisor, and I would like to highlight this because we are in the Climate Smart Advisors project, and I think it's of a special interest what the role of the advisor can be in supporting farmers in forage production and digitalization as well. The main mission of EGOPEN GPS is how to support farmers so that they can make their existing machinery smart. So they enable their machines to conduct some precision tasks, such as auto steering, section control, variable rate applications, and others. So Balázs is working as a consultant. He is assessing each farmer's unique condition. He prepares a plan, then help in the installation and setting up of the technology. And also they provide support, continued support for the farmers. EGOPEN is a community-based approach, and they combine open source, open access technologies, networks, and software with affordable hardware components to achieve comparable or sometimes even better performance than expensive commercial solutions. And it's more flexible for the farmers who are interested in the technical details to update and to customize to their needs better. So I hope that our contribution will supplement nicely the previous presentation when we heard about some commercial systems already. Open GPS is not specifically developed for forage production, but today we will hear about some specific examples as well in relation with forage production and the quality of the harvest as well. So I would like to ask Balázs to contribute now with your presentation. Thank you.
Hello, I hope my voice will be good and I have no internet problems. So here we go. I do believe that precision guidance is really for every operation on the farm. So as Laszlo introduced the Open GPS, it's an open source auto steer solution developed by farmers for farmers. So it in my opinion, really makes life easier. There's a B. Sorry. So when we look at the grassland operations, there's usually repeated passes with different implements. We started mowing, then sometimes we TED, sometimes we not. Then we rake it together for the baler to follow. If we use auto steer, and this can be resulting in unified rows for the baler. It also reduces the fatigue on the operator, and normally we say that there's repeatability, but for mowing you actually don't really want to have that repeatability. You always want to have the mower lit different lines for reduced compaction. And it also comes with the low-cost RTK correction, which can be either based on your own RTK base station, or there are some community solutions for RTK corrections that also works with all the other brands out there. So why do guidance matters in grassland? It really means, as I said earlier, many repeated passes over the same field with a different implement. The overlap during the mowing is a waste of fuel. During the tedding, it can negatively impact the outcome because you are not turning it over, but turning it over and back. So that's really not good for the feed. If you are missing strips, that requires extra passes. I'm pretty sure everyone has seen that or been there. If we are looking at irregular fields with slopes or poor visibility, it's really hard to keep up. There are also some crops that you need to take care over night or really early in the morning. So having a guidance system really makes life simpler. And the long working days after a whole week can really make you feel tired. I'm not going to say that having an auto steer is going to make you relaxed by the evening, but at least you are going to feel a bit better. It certainly won't feel like you've spent 16 hours in the tractor. So what does Open GPS bring to the farm? My video is a bit, yeah, there's a bit of lag in my slides, sorry. So this open source system can really grow with the farmer The software is free, so you don't need to pay for that. The hardware do have some cost, but the manual Lightburg guidance system could be achieved from a couple hundred euros. This is with centimeter precision. It does have all the bells and whistles like the commercial assistance or AB lines, curves. We can move around the boundary, the field painting, section control. Any external GNSS receiver can be connected to it. We usually suggest to use an external GNSS receiver for the accuracy sake of it. A normal GPS receiver in your phone is accurate up to a couple meters. Best conditions maybe a meter, but the repeatability won't be there. An external GNSS receiver that you can connect also to your phone gives you a centimeter precision. So how does a Lightburg guidance system looks like? In that case, we obviously not talking about any hardware for the steering. The driver needs to follow the line on the screen. Usually, this is used to make new passes in the field. As you can see on the screen, it comes with an external antenna. There's a GNSS receiver that you connect to the tablet, and that's it pretty much. And it's really an easy thing to start before you think about going into the auto steer part. So, how does the auto steer looks like? What benefits does it have? It doesn't just allow you to split the field into even parts, but it can also keep the tractor on the line automatically. So imagine if you are moving and it could do a 5 centimeter overlap from morning to the evening without missing a beat. That's what auto steer can do. Our solution is basically using the same antenna, same tablet, but the GNSS receiver is moved into a control box that also takes care of the slope compensation. So with this, you also are able to go on side hills and not have any problems because of the slopes. As for turning the steering, we suggest to replace the steering wheel, install a new electric motor that can take care of that. There are some other solutions too, like tapping into the existing hydraulic lines of the tractor, or when it comes with steer-ready pre-equipped, we can control it over the CAN bus. This is the most common and the easiest to start with. The same 2 centimeter accuracy as with the line guidance on the antenna, and generally speaking, it can do a couple of centimeters while driving the tractor. So, grassland workflow. How I would tackle this problem. During the mowing, we could create the base pattern for the field, define the AB lines, and then the tedding could be done in the same AB line, or I've also seen some tedding work happening across the field. So not necessarily following the mower. It's up to you how you want. But then the raking, baling is also happening on the same direction, same path. So this saved AB line can really support the whole operation chain. Of course, you can change the direction between the cuts or operations for the reduced compaction. It's really up to you. So, practical example, and I hope I will be able to demonstrate this too on the tablet. So, you move around the field like you normally would. This creates a pattern that we can use to define the field boundary. For this, we just need to enable the coverage mapping. And then there's a cool tool called boundary tool that can generate the boundary based on the mapped area. And once we have the boundary, so you can see on the right side of the screen, we can take an overview look and define the AB lines there. So let me try and show this in practice. So here I've done a couple passes around a field. What we can easily do is go into this boundary tool.
Balázs, can you hear us?
And then
Sorry, Balázs, can you hear me?
I just hopefully all around
Balázs, can you hear me?
the field and map the boundary for us. Yeah,
I think your connection is perhaps a bit slow. So when you open the software, it froze a bit.
Okay.
Yeah, maybe you can switch off the camera.
Yeah, I already did that. I tried to join back from the computer. Okay, good. And then I share my entire screen. Good. So hopefully we are back. Okay. So it did map all around the place. I hit save. So now we have the boundary defined, and then from the track line, we can see the whole field from the top. So maybe given the shape of the field, the best line is not always a straight line. I can also drive in a curve. So I would define here a curved line, and then you can just start your operation based on that curve. And of course, at the end of the field, we can turn around. So this is all possible with OpenGPS. I hope this was somewhat visible. So let's go back to the slideshow. So as I mentioned, it has RTK. So, but what does RTK do? It allows centimeter level positioning, and also it can navigate you back to that same coin-sized area over and over as many times you want. Our solution is based on mtrip, so it communicates over the internet, and so far it works with all the receivers. The XML high quality antenna really improves the signal and positioning, so that's why we use that. So what correction options do we have? Usually these correction options runs between 3 and 500 euro per year per machine. Our solution is really like a one-time investment for 500 euro, and the base station covers like 20-30 kilometers of a circle. So usually that's a much bigger area than you would like to travel with the tractor. There are many community-based networks. The first one of them was RTK2Go. Then we have the Centipede RTK, and also we have some other solutions. In Italy, it's not really popular yet, but should have here somewhere the map. I hope it will come up. Ah, okay, maybe later. So that's for the RTK correction. And what's the basic hardware concept for an open GPS? It runs and requires a Windows tablet or laptop. You can also take the desktop, but it's not really comfortable in the tractor, so we generally suggest to grab a Windows tablet with touchscreen. You need the GNSS receiver to have the correct positioning, and then depends on what you want to achieve. If light bar guidance is enough, then we can stay here. If not, then install a wheel angle sensor and figure out a way to turn the wheels or the steering wheel, and off you go with auto steer. For the installation and calibration, I usually say that this is like a one-day job. All the systems, no matter what you look at, requires installation and calibration. The antenna position measurement is really necessary, and AgOpen GPS really requires the wheel angle sensor to be calibrated precisely, so it knows where center is and what are the maximum limits for both left and right. Once you have done that, the steering response must be tuned. So how aggressive it should try to get on the line, stay on the line, and how big of a movement it should try to introduce to stay on the line. The higher the speed, the more quicker and precise movements are required. So generally speaking, if you are just interested in going 6 to 8 kilometers per hour, you can probably skip most of these calibrations and it will be fine. If you try to do this like 15-20 kilometers per hour or over that, these calibrations are really necessary. Also, there's the safety mechanism, so those needs to be in place, be usable. So when you grab the wheel, it should be you controlling the actions, and the auto steer should turn off. At the end of the day, it will be always the operator who's blamed for any damage that occurs. So if you feel that it might not fit next to the telegram pole, take the wheel, go slower, and don't just enjoy the show of hitting the telegram pole and knocking out the electricity in 3-4 pounds nearby. We have all seen that happen. It's really not fun. You need to call the electricity company to come back and reinstall the line that you just take out because you didn't pay attention. We also have section control, although I'm not quite sure if this really the target audience for the grassland operations. But if you are applying fertilizer on the field, then having accurate passes and automatic section control can really help a lot with those operations. We support many of the protocols that exist, and also for the newer systems like isobus, that's also possible. For very old systems like pre-isobus or pre-section control solutions, we have some custom hardware that we can install to make those systems also up to date with the latest technology. So I believe that precision farming can be accessible for everyone, really. Anyone can benefit from the guidance and the auto-steer solutions. The open source software lowers the entry costs. The budget RTK corrections can really help you avoid the yearly hectic and expensive RTK correction fees. Everyone starts with a light bar, and then usually they upgrade to the auto steer solutions. The farmer stays in control of the system and the tractor. So that would be it from my side. Thank you.
Thanks, Balázs, and maybe again you can mute yourself.
Sure.
Because of the echo, sorry, just because of the echo. Yeah, as you could see, Balázs joined us from the farm. So sorry for the connection problems. Still in the countryside, this can happen in Hungary. You have a weak signal for the internet, maybe not for the RTK, but for the internet you can have some drops. But yeah, I'm also happy because we can name today's event not just a webinar, but also like a farminar. I don't know how many of events in our project actually were joined directly from the field. So I think it's also nice to have this kind of experience. And back to you, Alex, how we continue.
Okay, thank you, Laszlo. Also, thank you to Balázs. I agree with you that it's a very interesting webinar when we have the direct link with the farmer, with the fields. So I think it's another value on this webinar. I think also was interesting because we had also another point of view that is open source option. So I think also with both presentation we had the to kind of the technology that we can use for the haymaking and how so which kind of technology we can use to optimize our field operation, our field activities, and at the same time how we can increase or maintain the quality of our forage, because we know it's not important to only to harvest the forage, but it's very important to harvest the high quality forage in order to reduce not only the cost, but also the environmental impacts, because as we saw in the previous webinar, the quality is strictly linked also to the animal feed, and as a consequence to environmental impact. So thank you again for both presentation, and I don't know if someone has some question on this for this presentation. Okay, I have a first question for Balázs. This, maybe I forgot the information, but where we can find this software, open source software, and if it is available in different languages. I mean, the English, I think not.
Yeah, well, it has like 20 something languages, and you can download that from ogopengps.com.
Okay. Thank you. Thank you very much. Other question? So I suppose the presentation were really clear. If no,
Yeah,
no
I think, Alex, that it will be published what you recorded. I mean, the video on the website of the project or on the YouTube. So I guess we can add some links under the video if someone is more interested in both presentations. Of course, it is shared with project partners in the back office, but for the others who are external visitors, let's say, to today's event, they can also find additional information there.
Yes. Usually, yes. The presentation is recorded, and then I will send to the coordination, and then they will put in the YouTube channel. I think. Okay. I don't know if Lorenzo, if you want to add something, or if you think that could be some link between your presentation and Balázs' presentation, and
actually not. I asked this to my professor if we have something to share about. Okay. No.
Okay, so if no more question or no more things, I think we can conclude this webinar. And thanks again to Balázs and Lorenzo. And okay, keep in touch. I don't know, Laszlo, if you have one more webinar organized from your side for Climate Smart Advisor project or not.
Not in the first part of this year. We already organized 2 webinars, so maybe in the autumn.
In autumn, okay. So
and also during the meeting in Greece, I think there will be physical meeting, and we will have a session with between 3 projects and between various thematic areas. So surely there in person, and then in the autumn, I think another online event. So we are already planning the topic for that with you together, of course.
yes, we will meet in Athens, October. That's true.
Okay.
Very good. So thank you to all for the participating, and keep in touch, and see you next time. Thank you also to Professoressa Roberta Martelli for her support, and bye-bye.